Hi guys. Today we're moving on to section 2 of chapter 6. We're still going to be solving a system of equations, but we're no longer going to do it by graphing. In this section, we'll be solving the system using a method called substitution. Since we will not be graphing today, you can do your notes on regular lined paper. To solve a system of equations using substitution, you need to have one of the two equations in the format of either x equals a bunch of stuff or y equals a bunch of stuff. So remember that a system always has two equations. So only one of them needs to have one of the letters be all by itself. One of the letters is isolated. And it doesn't matter which equation it is, and it doesn't matter what letter it is, just one letter all by itself in one of your two equations. In today's video, everything will already be set up and ready for you to do substitution. Here is our first example. When I'm doing substitution, I personally like to use colors. I find it helpful to color coordinate things. My first color that I'm going to use is the color red. The first thing you should do is you should identify which variable is all by itself. And in this problem, it is the letter x from the first equation. It says x equals. So I went ahead and wrote that letter x in the color red. And I'm going to write every x that I see in the color red just to help me identify them. Now, since the first equation tells us that x is equal to 2 minus 6y, that means that anywhere I see the letter x, I can replace it with a 2 minus 6y. And so what I'm going to do is I'm going to substitute 2 minus 6y into the x of the second equation. Now, everything else in that equation is going to stay the same. So it's still going to have the 1/2, it's going to have the minus y, it's going to equal 1. But what I'm going to do is I'm going to scribble out the letter x. And in its place, I'm going to put a 2 minus 6y. Notice that everything else is still there. Only thing that changed was the x. When you're substituting it in, make sure to surround it with parentheses. That will help you remember that your next step is to distribute. So now I'm going to distribute my 1/2. When you're multiplying something by 1/2, it's the same as dividing by 2. So in reality, I'm doing 2 divided by 2 and 6 divided by 2. My personal preference is to next combine like terms. So I'll be combining together the negative 3y and the negative 1y. Then we'll subtract this 1 from both sides. And finally, we'll divide by the negative 4. Now, 0 divided by anything is still going to be 0. And I have found one of my two answers. Now, we are still solving a system like we were doing earlier this week, which means our final answer must be an ordered pair. This is not an ordered pair. This is half of an ordered pair. So we're not quite done with this problem. You do need to keep going to make sure that you're always getting an answer for x and y. Now that I have found my y number, I can do substitution again to find my x number. What we're going to do is we're going to take the y, and we're going to substitute it into one of these y's up here. Now, it does not matter which y you choose. You'll get the same answer either way. In my personal opinion, I like to always use the equation that's already set up as x equals because it'll take less work. So I'm going to take the 0, and I'm going to plug it into the y of the first equation. And I simplify this. 6 times 0 is 0, 2 minus 0 is 2, and I now have both my answers, which I will write as a single ordered pair. Don't forget, ordered pairs are in alphabetical order, so the x must go first and the y must go second. My final answer to this question is 2, 0. Let's try another one. The first thing you should do is identify which letter is all by itself. In this problem, my letter y in the first equation is all by itself because there are no numbers or symbols with it. That means I'm going to find my letter y in my second equation, and that's where I will substitute. Okay, so it's important that you identify the correct variable to substitute into. It's also important, again, to surround it with parentheses so that you know to distribute. When you get to this step, you should have a single equation with one type of variable. In this equation, I only have the letter x. It's written twice, but it's both the letter x, so that's really important. If you get to this step and you still have both letters, an x and a y, you substituted incorrectly. In this problem, I will be distributing a -5. So make sure you do -5 times -4, which is +20. I'm going to combine like terms. I'm going to subtract the 20 to the other side. And finally, I will divide by the -13. And I get my first of two answers. This time, I found my letter x first. X is 3. To find your second answer, you'll need to take your first answer and substitute it back into one of the original equations. Don't substitute it into the new equation you created. We're trying to find the letter y, and that equation does not even have the letter y in it. Now, again, I prefer to use the equation that's already set up as y equals because it takes less work on my part. So I'm going to plug it into that equation. 3 times 3 is 9, and 9 minus 4 is 5. And my final answer, ordered pair, alphabetical order, is 3, 5. Let's do one more just for good luck. In this problem, the letter that's by itself is the letter y in the second equation. So sometimes it's the first, sometimes it's the second, sometimes it's y, sometimes it's x, sometimes it's on the left, sometimes it's on the right. Like, it doesn't matter as long as you find the letter that's all by itself. And so I'll be taking the second equation and plugging it into the y in the first equation. Don't forget your parentheses so that you remember to distribute. Now in this problem, I have x minus x, and x minus x is 0x. So my x's actually cancel out. And so this one is a special case. So now we have 8 equals 1, and there are no more variables. So I'm no longer going to be solving for a letter because I don't have any letters to solve for. So what I need to do next is I need to ask myself, is this true? Is 8 equal to 1? And the answer is no, it's not true. So if all of your variables cancel out and you get a false statement, then the answer that you write is no solution. This concludes today's video on substitution.